everyone. This is Aditya from Sri Venkateswara College of Engineering, and I welcome you all to this session in which I am going to talk about Finder's algorithm in machine learning. Let us look at the agenda for this session. First, I'll give you a basic introduction to Finder's algorithm, followed by how does it actually work. Then I'll talk about a few limitations of Finder's algorithm. And moving further, I'll tell you about how we can implement Finder's algorithm. Finally, to sum up this session, I will show you a use case using Python. I hope you guys are clear with the agenda. Also, don't forget to like and subscribe to my channel and press the bell icon to get the latest update. Now, without wasting any more time, try to understand Finder's algorithm in machine learning. So, what exactly is Finder's algorithm in machine learning? Before learning about the Finder's algorithm, we have to understand these following topics that I am going to talk about, which is concept learning, general hypothesis, and specific hypothesis as well. So, what exactly is concept learning? So, let's try to understand the concept learning with real life examples. So, most of human learning is based on past instances or experience. For example, we are able to identify the type of any vehicle based on a certain set of features that are defined over a large set of features. These special features differentiate the set of cars, trucks, etc. from a larger set of vehicles, and these features that define the set of cars, trucks, etc. are known as concepts. Similar to this, machine can also learn from concepts to identify whether an object belongs to a specific category or not. So any algorithm that supports concept learning will actually require the following: that there is a training data, the target concept, and actual data object as well. So this is all about concept learning. Now let's try to understand what is a general hypothesis. Hypothesis in general is an explanation for something, and on the other hand, the general hypothesis basically states the general relationship between the major variables. For example, a general hypothesis for ordering food would be like, I want a burger or I want a pizza. And we denote it with the equation that I'm showing you over here, which is G is equal to a bunch of question marks. And now, coming on the specific hypothesis, the specific hypothesis fills in all that important details about the variables given in the general hypothesis. The more specific details into the example given above would be like, I want a cheeseburger with a chicken pepperoni fillings and a lot of lettuce. We are giving details about the variable. That would be our specific hypothesis. We write or we denote the hypothesis with a 5 symbol. Now that we know about general hypothesis, specific hypothesis, and concept learning, let's talk about Finder's algorithm. The algorithm follows the step that I am telling you. The first step is to initialize H to the most specific hypothesis, that is, giving the details into the example. And after that, the Finder's algorithm only considers the positive examples and eliminates all the negative examples. For each positive example, the algorithm checks for each attribute in the example. If the attribute value is the same as the hypothesis value, the algorithm moves on without any changes. But if the attribute value is different than the hypothesis value, the algorithm will change it to a question mark. Now that we are basic explanation of Finder's algorithm, let us also take a look at how it actually works. Here is a flowchart how the Finder's algorithm actually works. The step goes in like the process start with initializing H with the most specific hypothesis. Generally, it is the first positive example in the dataset. Now, I'll be clearing out the positive and negative example. when I'll be telling you about how we can implement the finders algorithm. So don't worry, guys. The second step is we check for each positive example. If the example is negative, we will move on to the next example. But if the example is a positive example, we will consider it for the next step, which is we will check if each attribute in the example is equal to the hypothesis value. Now, if the value matches, then we make no changes at all. But if the value does not match, the value is changed to question mark. And we will do this until we have reached the last positive example in the dataset. This is how finders algorithm actually works, guys. As you can see in the diagram, also we have a flowchart. We are initializing H first of all, and then we are checking for the next step subsequently. Now, keeping all this in mind, a few limitations of finders algorithm as well. Let's take a look at a few of these limitations of finders algorithm, which are there is no way to the hypothesis is consistent throughout the data. There is no way you can actually determine if the hypothesis that you have made is going to be consistent through the data. There might be several inconsistencies as well. The next one is inconsistent training set can actually mislead the finders algorithm since it ignores the negative example. As we have seen in algorithm as well, we are skipping the negative examples altogether. This actually might mislead the finders algorithm. The last but not the least we have is finders algorithm does not provide a back training technique to determine the best possible changes that could be done to improve the resulting hypothesis. There is no way you can backtrack to whatever changes that you want to make. So we don't have that in finders algorithm, which is actually a limitation in one of its kind. Now that we are aware of the limitation of the finders algorithm as well, let us look at a practical implementation to find S algorithm. To understand the let us try to implement into a smaller data set with a bunch of examples to decide if a person wants to go for a walk or not. As you can see in the image, we have a data and the concept of this particular problem will be on what days does a person like to go on a walk or not. For this, we have a time, we have weather, and we have temperature, humidity, wind. After that, we have a decisive parameter that is if he goes or not. That's going to be either yes or no. Yes and yes. So in this case, it is yes, no, yes and yes. Basically, a positive example is whether it's written yes, and wherever it's no, it is going to be a negative example. While we are implementing the finders algorithm, it will actually eliminate this, or it will skip this example which has no as the negative example. Looking at the data set, we have 6 attributes and a final attribute that defines the positive or negative example that I have told you already. In this case, yes is a positive example, which means the person will go for a walk. Now, the general hypothesis is which H is 0, the time is morning, whether it is sunny, the temperature has to be warm, and the company is yes. Yes, the company, humidity is mild humidity, and wind is actually strong. So all these parameters are going to be put inside the general hypothesis. So this is our general hypothesis, and now we will consider each example one by one, but only the positive example. We'll have to skip the negative example. Now, H1 would be like the time would be morning right now, so we are going to write it as morning. After that, sunny, it's going to be sunny as well. The temperature is moderate, so we'll put a question mark over here, and the company is yes. Humidity is a normal and a different value. So we'll put a question mark again. Wind is strong over in the general hypothesis and in the normal. So we'll put a question mark again. and there is no change in the DCG parameter, that is a positive example. And we'll move on to H2. Over here, because that's the last example in our data set, which is also a positive example. Now, the question comes here. The first parameter, that is time, is actually evening over here. So we'll put a question mark again. The weather is sunny, so we'll make no changes, and the temperature is cold. So we'll make a question mark again. Then the company is yes, so no changes. Humidity is also a different value, so we'll put a question mark over there already. Then the wind is strong, so we'll put a question mark over there as well, because we had already encountered normal, which is a different value from the hypothesis. So this is how we will get, I have replaced all these values, all the different values in the general hypothesis to get a resultant hypothesis. Now that we know, we can actually implement the finders algorithm. Let us look at an implementation where we'll be using Python as well. So guys, here I am in my Google Colab to just show you and implement a finders algorithm. So before I go on to that, I will just show you my CSV file that I have the data. So here I've taken 6 factors, that is the sky, air temperature, humidity, wind, water, forecast, and whether our final attribute, whether he's enjoying the sport or not. So this is a different example from what I have shown earlier, but it's just similar. So as you can see here, our first is a positive example. The conditions are the sky is sunny, the air temperature is warm, the humidity is normal, the winds are strong, the water is warm, and the forecast is safe. So he is enjoying his sport. So it is a positive example. The second one is also a positive example. The sky is sunny, the air temperature is warm, the humidity is high, the wind strong, the water is warm, the forecast is same, and he's also just enjoying his sport. So yes, this is a positive example. The third, as you can see, the sky is rainy, temperature is cool, humidity is high, wind is strong, water is warm. The forecast has changed, so hence this is a negative example. And our last instance, as the sky is sunny, air temperature is warm, humidity is high, wind is strong, water is cool, forecast is changed, and yes, he is enjoying the sport. So this is a positive example. So coming back to my Google Colab, so here I have the CSV file in my drive and I have imported it onto. So in this part of our code, we are importing that CSV file, and with the following code, we are loading that file as a CSV file using with open. This is the name of my CSV file over here in read mode. And then as you can see, all the data that is there is being read and stored in arrays. Okay. As you can see, this is your TR. Now, if I come down, you can see that I am printing the total number of training instance. What are the attributes? What is the initial hypothesis? I'm denoting it with 0. Okay, and if my attribute is yes, the algorithm will implement, and whatever changes are coming, I am putting a question mark for it. So I'll just run this code showing you. So as you can see, there are 5. Total number of training instances is 5. Initially, my hypothesis is 0, 0, 0, 0, 0. So my first training instance is 0, like, because we haven't started anything. As you can see, sunny, warm, normal, strong, warm, same. Yes, so yes, these are the same. This is my instance 2 from the general. This is a positive example. This is also a positive. So if you can see from the first and second one, what are the things that I have changed? And it is still a positive instance. As you can see, humidity has changed and remaining everything is same. So in place of humidity, I'll put a question mark because humidity is not a factor of this instance being positive or not. So here in place of humidity, I have put a question mark. Now coming to the third, as you can see, this is a negative example, so we'll be skipping this one. In finders algorithm, we do not consider the negative examples, and then so it will be same. the humidity will be question mark and there will be no changes. But if we go to the last instance, the sky is sunny, the air temperature is warm, the humidity is high. As you can see, the humidity is changing here from the first instance, but since we have marked it as question mark, we do not need to consider this. The wind is strong, the water has changed. As you can see, the first two positive instances were warm and now it has become cool, but still he's enjoying his sport. So we'll change water to a question mark. Forecast. As you can see, the forecast was same for the first two positive examples but has changed. So for forecast, we'll be putting a question mark. So as you can see, we are putting a question mark for this. Now, if we look at what are the hypothesis training instances that are responsible to consider whether A is enjoying his sport or not. So we'll just find out sunny, warm, and strong. These are the three specific hypotheses for the training instance. So as you can see, I have implemented this small finders algorithm. Thank you.